This is an RNZ podcast.
They say life is stranger than fiction.
When it explodes, it goes off in this fantastic green, horrible colour, sort of very reminiscent of Disney cartoons. If you've ever seen a Disney spell being cast, that's always green and sinister.
But sometimes what we see in movies or read in books is so incredible that it obviously couldn't be possible. Or could it?
The Haber-Bosch process essentially was called bread from the air because it allowed us to create fertilizer in a way that had never been done before. And probably billions of people are alive today because of that process. I don't want to give you the recipe on air. I think that might get me in trouble.
Welcome to Sci Fi, Sci Fact. I'm Brian Crump, and this is a podcast where we take science fiction's strangest ideas, weirdest elements, most unfeasible plot drivers, and explore if they could actually happen in real life. Maybe they already have. And in every episode, we bring in a scientist from New Zealand's McDiarmid Institute to explain the theories behind some of fiction's more fantastic flights of fancy, if any theory exists. In this special episode, UK-based award-winning science journalist and broadcaster Kit Chapman joins us to discuss Wildfire from Game of Thrones, a flammable liquid causing fires so hot that water doesn't stand a chance.
I remember reading an old sailor's proverb. Piss on wildfire and your cock burns off.
Oh, no, I have not conducted this experiment. It could well be true. The substance burns so hot it melts wood, stone, even steel. After the dragons died, wildfire was the key to the Targaryen power.
The contents of this room could lay King's Landing low. You won't be making wildfire for my sister any longer. You'll be making it for me.
That's right, if you want to shift the balance of power in Game of Thrones, you get control of the manufacture of wildfire. Now, it's flammable, unstable, explosive. It doesn't stop burning until you put sand on it. That sounds like oil to me, Kit.
It sounds like some really nasty stuff, and actually there is a similarity to some very historic stuff, which was also called wildfire back in the day. And that was a substance called Greek fire, which, you're right, it does sound like oil. It sounds like napalm. Floats on water, it burns, it's got that stickiness to it. But the fact is we don't actually know what Greek fire, this stuff that existed, was. So it's all a bit of a mystery.
And it was used by the classical Greeks?
No, so Byzantine Greeks are actually Romans. The Roman Empire, if you remember, splits into the West and the East when it starts to collapse in on itself. The Western Roman Empire becomes the sort of the Latin Roman Empire, breaks into France and Italy. But in the East, which is ruled in Constantinople, today's Istanbul, that becomes the Byzantine Empire. And they were also called the Greeks occasionally. So it's actually this empire that lasts for about 1,000 years after the Roman Empire. It falls in sort of the 15th century. That actually creates this Greek fire. And as you say, we think it's some kind of napalm. Certainly it involved some kind of petroleum, probably mixed with pine tar, sulfur, something like that. And it would create this horrific effect where they could use it in what's described as flamethrowers, essentially. They use it in sea battles to defeat their enemies.
And it was one of the things that kept people from taking Constantinople over, protected them from invasion for a long time. They lasted a long time, didn't they?
Yeah, very long time. It was a mystery that sort of scared their enemies. We know that people were afraid of it. They wrote extensively about it. Constantinople actually only fell after the Crusaders were kind of let in 1204 and sort of started looting the place in a sort of a surprise attack. And so that's how Constantinople fell. And after that, things got a bit hairy for them, and the Ottoman Turks eventually took over. And so this is probably the inspiration for Game of Thrones' Wildfire. We know that in Game of Thrones, originally the Targaryens, the rulers of the kingdom, they used dragons to keep people in line. But then the dragons all died out. It turns out the Targaryens weren't very good at keeping pets. And so they started looking for alternatives, and their alchemists, their pyromancers, which we heard in that clip there, looked and created wildfire, this strange green substance that, as he said, it burns so hot it can melt wood and stone and steel, and of course flesh.
Napalm. What is napalm? I mean, I hear that used a lot, this napalm bombs, and I mean the horrible use of such weapons going back to the Vietnam War, but what is napalm?
Well, I don't want to give you the recipe on air. I think that might get me in trouble. But essentially, napalm is a mixture of a very flammable petroleum, so that it will ignite very, very easily, and something that's very, very sticky. And that is really the horror of napalm. It's the combination of both the fire and the stickiness. So it stays on someone and will cause a lot of damage. It stays on whatever you throw it on. And of course, this means that it also floats on water. And when it burns, the problem is you can't just put it out. There's a chemical reaction going on there. It's an exothermic reaction. It generates heat. And you can't just extinguish it with water. You need, as the clip said, to put sand on it. It's the only way you can actually get this out. But there's even worse stuff than napalm that this could be linked to, this wildfire.
It does therefore sound like we've got a pretty easy connection between fantasy and reality here. What are some of the other things that wildfire does that are a bit more fantastical?
Well, there are several things that wildfire does that we can replicate in the real world. The interesting thing is that they sort of combine in a way that doesn't necessarily make sense. One thing, as I mentioned, is this green essence to it. And when it explodes, it goes off in this fantastic green, horrible color, sort of very reminiscent of Disney cartoons. If you've ever seen a Disney spell being cast, that's always green and sinister. And wildfire is very much the same thing. We can do that with flame tests. Barium is commonly used in fireworks to produce that green color. But barium wouldn't be used as an explosive, which we know wildfire can be, and wouldn't create this burning that wildfire does. And really, that's the second property of wildfire that we need to look at, this explosive nature. Because while napalm burns, it isn't known as an explosive, which later on in Game of Thrones, and I don't want to ruin it for anyone who hasn't seen it, but one of the schemers, and there are a lot of them in that series, decides to wipe out her enemies by blowing up a church with all of them in it, and takes half of the city with them when this stuff goes off. So it's incredibly explosive, and that's the other property we really need to look at.
Here's a question. The scene that I played, it's all in the vault. It's in canisters. Now, how would you have a substance which is as flammable as this, but yet is able to be stored in a relatively crude way?
Well, we can store this. It's all about how it actually is set off. Most of these things will require ignition, and what we're looking at, as I said, is a chemical reaction, and you need sometimes to start those off. One of the good examples of this kind of material that would sort of start things off is when you're lighting a fire. You know, you can walk around with petrol, you can walk around with oil. It doesn't ignite until you actually put it to a flame. There are substances in the real world that don't do that actually can spontaneously ignite in air. A good example is white phosphorus, and that has to be stored actually in water, because as soon as it's exposed to air, it begins to oxidize, it ignites spontaneously, and it will continue to burn. And like wildfire, it won't stop until it is put out in sand.
Is phosphorus, though, a liquid? White phosphorus?
No, white phosphorus is usually a solid, which again doesn't quite fit. There are a couple of potential candidates that we do have in our real world for wildfire. One is nitrocellulose, which people will be very familiar with. The other one is ammonium nitrate, and ammonium nitrate will create a terrible explosion. Again, this is not a liquid; it's usually kept as a solid. But there was an explosion in Beirut, I think people will probably be very familiar with.
Yep. And
that was an ammonium nitrate explosion. So it'll show you the potential.
I mean,
so ammonium nitrate is NH4NO3. And so there's lots of nitrogen there, lots of bit of hydrogen, a bit of oxygen as well. And it will create an incredible bang when it goes off. What we're actually seeing is two different oxidation states in this particular molecule. And so when an exothermic reaction, one that gives off heat, occurs, the nitrate acts as an oxidizer and the ammonium is a reducing agent. And so the reaction will very rapidly produce gas. That gas will create pressure. And when there's pressure, you'll get an explosion.
You said a reducing agent, the ammonium. So what do you mean by that? What's it reducing?
So this is by oxidizing and reducing agents, we're talking about how electrons are transferred. So when a molecule breaks up in a chemical reaction, it's destroying the bonds that are between the atoms. And if you gain energy, essentially, you release energy when you break those bonds, you have an exothermic reaction that will produce heat. If you require more energy, that will create an endothermic reaction. It will get colder. And so that's what gives you your heat, things like that. But when ammonium nitrate is breaking off, as I say, it's essentially the two different parts of this molecule. As they break apart, they begin reacting with each other. And that's what makes it so potent.
You need an ignition, and then what? The molecule breaks apart and then reacts with the new constituent parts in a more violent way.
Precisely. That is exactly what happens. As soon as those molecules start to break apart, they start reacting with each other. And usually, if the reaction is completely clean, the products would be something called dinitrogen, water, oxygen, but you also get things like nitrous oxide. All of those products are gases. So this solid is breaking apart and it's releasing gas. And that's creating pressure, that travels outwards, and that gives you the detonation.
Why, now, in the case of that horrific explosion in Beirut, why was it that this reaction turns from a fire into a massive explosion so quickly? In a matter of milliseconds, it seems.
Yeah, it was incredibly frightening, and you get this sudden huge plume of smoke, and the red-orange color to that smoke is very, very signature of nitrous oxide. That's pretty much how most chemists would recognize it, and that's because of this incomplete decomposition of ammonium nitrate. What almost certainly happened was there was another fire, and then that got to the ammonium nitrate stores, and once that happened, the whole thing would go off.
What do people use ammonium nitrate for?
Well, it's actually really useful for fertilizer. And that's the predominant reason that I assume it was being stored in Beirut. There have been several explosions throughout the years with ammonium nitrate. Nitrates themselves have been valued since the early sort of 19th century, predominantly for fertilizers, but also for gunpowder and for weapons. Initially, the world's supply was from bird poo. And we got our nitrates predominantly from South America along the Atacama Desert.
Yes, and also in parts of the Pacific Islands as well. Nauru.
That's right.
They gave us a lot of our phosphate here in New Zealand.
Very much so. And wars were fought over islands, the Guano Islands wars in the Pacific, and certainly the War of the Pacific. In fact, the reason that Bolivia doesn't have a coastline is they got into a war over bird poo with Chile and lost. So there's a fact for you. These chemicals are so important, so vital to the world that people would actually sort of fight wars over them. And
that was a fight for the nitrate for its use as fertilizer or as an ingredient in weapons?
Probably both. So it was exported by Chile, Peru, and Bolivia throughout the 19th century. Things changed in the early 20th century. We actually learned a process called the Haber-Bosch process, partly invented by Fritz Haber, very famous chemist, although famous for all of the wrong reasons. The Haber-Bosch process essentially was called bread from the air because it allowed us to create fertilizer in a way that had never been done before. And probably billions of people are alive today because of that process. The problem is that Fritz Haber was an incredibly controversial individual. He won the Nobel Prize for that discovery, but he also invented chemical warfare. He was the first person to use chlorine gas against the Allies in the First World War.
What was key about the process that he invented that made it cheaper to make these inorganic fertilizers?
Well, one thing is you don't need to transfer bird poo across the world. So you can start making it wherever you are. You can also very, very easily do it. And so it just freed up everyone to do it. And these days, the Haber-Bosch process is used around the world to make fertilizer very, very effectively. All the ingredients you need are in the air. You literally pluck them out. Problem is, it does require an awful lot of heat and pressure to do this. And probably making ammonia in that way has probably contributed very significantly to climate change.
Right. Okay. So the Haber-Bosch process, because we still import a lot of phosphate these days from North Africa here in New Zealand. So I'm assuming it hasn't completely replaced that way of getting an organic fertilizer.
It hasn't completely replaced everything, but certainly the production of ammonia in terms of the industrial process, the Haber-Bosch process, I think the majority, 144 million tons of nitrogen was produced in 2016 through this process. So it's a huge industrial scale process that's actually used around the world.
Now, is it ammonium nitrate or ammonia nitrate?
Ammonium nitrate
okay.
is the substance that was in Beirut. Ammonia is a different substance, but yeah, ammonium nitrate.
Now,
and
what is it about?
What
is it about that molecule that's useful to plants?
Well, it's the nitrates. So one thing we need for plants to grow is obviously we need soils that are rich in the nutrients they need, and the nitrates are incredibly important for plant growth. So that's something we're always looking to sort of re-get into the soil. Quite often, people will use crops that things like rapeseed oil, for example, that will actually reintroduce nitrates into the soil. But in terms of industrial processes, you can't always do that, and so occasionally we use fertilizer in that way.
The ammonium is not so useful to plants, but it's just if you want the nitrate, you've got to have it with something else, and ammonium is one of the easiest ways to have that.
Yeah, it's like booze. You need somewhere to deliver it. You can choose whiskey or beer or whatever you like, but really you want the alcohol.
Yeah, but of course the alcohol comes with H2O, doesn't it?
It does indeed. It does indeed. So really, that's the potential explosive nature. And going back to wildfire, the ammonium nitrate explosion is the kind of explosion that we do see with wildfire. So it's a combination of these different areas that we've spoken about. There's the ammonium nitrate, which acts as the explosive. There's the potential to burn that we've seen from napalm, and there's that strange color, which is probably from barium. So it's actually taking three different areas from actual science and combining them into this horrific substance that in Game of Thrones is used against boats and armies, and later is used to blow up someone's enemies.
Thanks for listening to this episode of Sci Fi Sci Fact, hosted by me, Brian Crump, produced by Andrew Robertson, and of course, made possible thanks to the incredible knowledge of those brilliant scientists at the MacDiarmid Institute. You can find more episodes of Sci Fi Sci Fact on the RNZ Podcasts page. RNZ Podcasts are also available on Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or pretty much wherever you might find your podcasts. And make sure to follow us so you don't miss out on any new episodes.